Good afternoon, guys. Interesting topic, right? Security. My name is Gaurav Bhatnagar. I am senior engineer and tech lead for Astra and Trident. Um, so Arvind did talk about, he laid the emphasis on security and how security is on the forefront of everything that we do in NetApp, including our products. I'm going to build slightly on that and then slowly introduce you to Astra Trident. So basically, uh, the security, if you see, the security is not limited to one particular realm. There are various tiers of security if you want to really protect your application, right? It all starts from the cloud security. You guys are already doing it. Then it comes to your cluster. Your cluster needs to be protected. Then it comes to your containers. Your containers also need to be protected. And finally, your data, where the data is actually residing. I'm talking about the lowest tier where the data is actually residing and how we protect it. uh, as we know, data is the data is our backbone, right? Ravi mentioned about the importance of data. Arvind built on that, and the threat to our data is constantly evolving, and uh, not just evolving. The attacks are becoming more and more sophisticated. So our ways to protect the data should also be evolving and becoming more sophisticated. So in Astra, we do data at rest encryption. This is one of the many ways we encrypt the data. Basically, as and when your data is getting written to the disk, we encrypt it. So just in case, there are threats of insider threats also. Your data, somebody stole the hard disk, somebody stole the equipment. Your data goes into the wrong hand. It is still even protected because it is encrypted. We also do something called LUKS, Linux Unified Key Setup for volume encryption. This is the client-side data protection, data encryption, basically. The previous one was the server side. This is the client side. So even before you're writing on the client side, even before you send the data onto the disk, you encrypt it. So all these things are done in Astra. Now, this was just the data at rest encryption, right? When your data is stored. What about when your data is moving between the clouds? Let's say Arvind talked about moving the data from one hyperscaler to other hyperscaler. What about the data threat to the data during that time, right? And the in-flight encryption comes into picture there. And not just between the clouds. What about when your data is traveling between the application and the PV or the storage? Somebody can hack there also. So the data in-flight encryption becomes even more important today, right? And there's an interesting use case also for that we have recently found out. Traditionally, people wanted a cluster as a unit of multi-tenancy. Okay, this is my cluster, this is for my application, this cluster is isolated, I'm good with it. But because of the resource pressures, the cost cuttings and everything, there are users who want a Kubernetes node as a single unit of multi-tenancy. In a big cluster of 10 nodes, 15 nodes, 20 nodes, I want 2 of my nodes to host my application. The rest of the nodes can be hosting other applications. How do you protect the data, right? So in-flight encryption comes very handy over there also. And how do we do that? So basically, Astra relies on a protocol called Kerberos, which is basically a secure authentication protocol in secure networks. We utilize that thing to provide the in-flight encryption. And as I said, the threats are evolving and becoming more sophisticated, and we keep on adding additional measures in our product to make sure that data is completely secured. Okay. Now, coming to Astra Trident, Arvind briefly touched upon NetApp's contribution to open source, right? Astra Trident is one of our contributions to open source, highly popular open source project. It's basically an open source dynamic storage provisioner and orchestrator to give your apps a persistent storage, right? It's CSI compliant, which is a standard for how your data is consumed, persistent data is consumed by your apps. and is fully managed by NetApp. NetApp takes care of managing every aspects of Trident, from releases to fixes to enhancements, everything. And it 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 is quite evolved in the way that it supports all major protocols that we have today: NFS, SMB, iSCSI, as well as NVMe. And the deployment is pretty simple, right? It is implemented as an external provisioner. It is implemented as an external provisioner and runs as a set of pods on your cluster, right? It has got basically two sets of pods. The Trident consists of two sets of pods. One is a controller pod, which basically takes care of your data management and your provisioning, basically. That's called the controller pod, and it can run on the control node or the worker node. The second set of pod is basically your node plugin pods, whose only job is basically to attach the storage that the persistent storage to your node, to your node which is going to access it, right? Apart from that, it also uses certain sidecar controllers also. Sidecar controllers basically makes your CSI deployment pretty simple and efficient, and it is also managed by the Kubernetes community. So we use the sidecars, right? Yeah. And as I mentioned, this is a highly popular product from NetApp. 800 plus unique users are there who are actively involved with this development. And few of the biggest bigwigs I would like to highlight here is Google, Microsoft, Yahoo, Verizon, Deutsche Bank. They all are users of NetApp and are actively involved with it. In the sense that they ask for the enhancement, they ask for the features, they ask for the bug fixes. They themselves do the bug fixes, right? At times, so basically highlighting the contribution that that open community or the open source community makes to a product. Yeah. So this was about Astra Trident, and okay, yeah, that's all from my side. I am happy to take any questions, and Arvind, if he's here, we'd be happy to take any questions. Okay, he's not there. Yes, please.
Yeah, so just going back to the previous discussion, which Arvind was talking about secure multi-tenancy and also governance.
There are some questions here for you.
Yeah. Yeah, so you were talking about governance, compliance, and as well as secure multi-tenancy and a lot of other aspects of DR and backup and recovery, right? So I feel there's a strong requirement for some sort of a policy-based mechanism that you might or may not have put into your platform. So is that there today? How are you actually ensuring the enforcement of many of these for example, if you look at secure multi-tenancy, how are you putting in network policies, node isolations, RBACs and all? Is that all configured on a manual basis, or you're written some scripts on your own, or what is the mode?
So mic is working, right?
Yeah.
Okay. So as far as multi-tenancy is concerned, that comes under what we call as the Astra Control portfolio. So the first thing is, what is your user schema, right? So which is typically in Active Directory or somewhere. So first thing is we integrate with Active Directory, and the next thing is what are the user roles that we want to assign, so which could be security groups within Active Directory. So we leverage what is already the standard industry practice today. Like in case of AD, this is how it is. So this is the user, this is the OU, these are the service security groups that can be created and associated with that. So back here on our side, what we do is the slide might be there somewhere. Yeah, so like for example, user roles. Each of these user roles could correspond to one security group, right? As in terms of what that individual can do. So you frame a group, and with AD integration on our side, which is on the Astra Control platform, we consume that, or we basically inherit those policies, and we will provide RBAC, access control, and the authorization based on that 1:1 mapping. You can either do it standalone, that is, let's say I don't have an AD integration at all. I just have 10 users, all of them are standalone. You can go about creating 10 individual users, And for each of those users, you can give them these roles. And within the roles, you also give them the resources that they play with. Like, for example, let's say app admin has got access to two namespaces, namespace one and namespace two. I could also have, say, app member who's got access to namespace one and namespace two. I can still do that.
So my question was more on the mechanism as to how you get this done. Is it a kind of inbuilt scripts that you have come up with, or are you using any policy as code
It's
mechanism?
a combination of both. So some of it is what is coded within our product itself, that is in Astra Control. So how we integrate with Astra Control and imbibe the AD policies, or basically which namespace needs to be presented to whom. So we also do GUI level masking as to, I mean, like typically when you run, say, kubectl get namespace, you can list the whole thing. But if a security account, a service account is locked down to a few namespaces and you do kubectl get namespace, you might not see the all, or even if you see all, you might not be able to create any resources within those namespaces, right? So some of those we leverage from the Kubernetes platform also as to what um, roles and role bindings offer for a namespace, and at the same time what can we do over that, operating one level above that and presenting that visually, because those namespaces and the PVs or PVC is a namespace scope resource, right? So the data is also kind of in a way bound to that namespace. So how do I go about ensuring the data that is presented or made available as part of the namespace to that individual? So that entire area is what we deliver through Astra Control. So we orchestrate that full thing, some capabilities natively from Kubernetes, and some of it is what we write as code and bring it together. Yeah.
So, Arvind, is it possible to use these capabilities for serverless technologies as well? Because that would not go through the kube controls and all that, right?
Yeah. So this is exclusively for Kubernetes, nothing for a serverless just yet.
Is there a plan for enhancement towards that?
As of today, no, because our starting point today is, if you're on the cloud, typically we need a service principal to begin with, or an IAM, some representation point, or even on premises, we at least need a kube config file, without which we cannot make any progress, because in the kube config, you know what that service account is capable of doing, right? So some level of boundaries are defined. But serverless is a different ball game altogether, and we are not. I mean, maybe futuristically, but not as of today with this portfolio. We are not looking at serverless just yet. Yeah.
Thank you. Uh, so my question is in terms of how do the users consume this? Like, is it a multi-cluster orchestration system? Does it have to be taken up as something like that, where like Rancher supports the similar mechanism is what I heard about or I've checked about. Where you can group multiple namespaces together and assign users and assign RBAC on top of it, of course. But then the consumption is that you have to onboard your clusters onto the Rancher system.
Yes.
So how is the consumption here for from the user perspective?
So we don't what do you say, compete with the Kubernetes platforms directly. So we operate one level above the Kubernetes platform. So like classic example, you brought Rancher, right? And Rancher is very what do you say, diluted in that case. You can either create a cluster from Rancher, or you can import a cluster and make it Rancher managed, RKE1, RKE2, like different form factors. So Rancher for me personally is one of the most complicated things out there in terms of what is the right way to do it in Rancher, right? But you're right. You can group with Rancher. In those cases, what we will do is we will acknowledge whatever policies you have put in Rancher as long as it is a Kubernetes object. Like even if it is a CRD, that's totally okay. Like how that policy is defined in Rancher, or is it sitting outside of Rancher? If it is outside of the Kubernetes ecosystem, we will not have visibility into it. But if you're creating the policy within the Rancher engine, then we will still have access to it. So we will be able to, what do you say, complement that and bring those capabilities into our multi-tenancy schemas as well. So if you say, hey, this is my user account in Rancher, which is having access to these namespaces, you can have the same user account ingested through the kube config over here, and whatever that individual is seeing is what we will also see. So straight away, you're building into that native capability. It works out of the box.
Got it. Thank you.
I just wanted to add one question actually regarding the storage part of it. Consider that I want to store PCI data in the NFS mount.
Which data?
PCI data.
PCI data.
Okay. Now, in this case, how will you protect the data? Because the NFS is actually mounted in the node and you are actually connecting from the Kubernetes cluster. Where do you get the access control? How do you manage that? Because I don't see any of that happening with this namespace and anything.
Okay, so PCI data. So basically, first thing is you want to lock down who gets access to the data, right? So we support read write one pod or read write one pod, read write many one pod. So which is basically exclusively that PV is available to that individual container. So if you want to lock it down at that level access mode, you can do that. The next thing is I think Gaurav talked about the pod to PV encryption, right? As to data traffic at rest, data traffic in flight. Both of those are encrypted as to who gets access to it. We also offer what is called as volume encryption. So your data that is at rest is also encrypted using your custom KMIP or your key management in the backend volume also. So we can offer you multiple levels of implementing security. And of course, back to this hardening over here in terms of you will basically play with the first two more: access control, audit, and accountability. So every read write action is typically logged with the UID GID as to who is coming in, who is logging in, what actions they are performing. So that entire inventory or the journal is built. And access control from our side, you can lock down the client access. That is, you can whitelist, you can blacklist who are the authenticated and authorized users who can access that. So like what I'm saying is within the deployment you can give a PVC name, right? Nobody is stopping you from doing that. So you can technically say, hey, my PVC is open. As long as an administrator can go and put it into their deployment, that PVC becomes part of that namespace, right? So that is a big gaping hole there. But what we can do is we can lock down there saying that, hey, if this is the range of network that you have for that particular service that you have, even if it is presented in the backend on the storage front, we will lock down the IP range or the client map to that whitelisted set of IPs that you give. So create an exclusive export policy as to who can access it, despite that being presented to any other manifest.
But I have a bit of a challenge there because you know that the PCI compliance tells that the access control should be different from the OS credentials or OS authentication. Now the problem is when you're mounting in the operating system, because underneath your NFS mount is actually mounted to the
On the
underneath.
worker node, yeah.
Exactly. Now the problem is you need to have different access because I can access the data from the worker node. How do you prevent that? Now that you don't do it. That's the problem we are in.
Yeah, so that is as such not a, I believe, not even a CNCF guideline as of date, right? We don't have a standardization on do you move one level up rather than mounting it at the node level? Do you directly mount it into the pod level? As long as the pod can run the NFS daemons, then we can move it one level up as well. So we don't need to mount it at the node, but we don't really know what image the pod is going to run. If it can serve direct NFS, then it can go one level up as well. So we can mount it into that, provided you have the L2 to L3 network bridge. Then yes, in a way, yes, we can still achieve that, but not with the existing CSI standards that are there put out by CNCF today. But we can bypass it though. It's definitely not a best practice because that is not a scalable design by any means.
True, true. Yeah, maybe I can have a following discussion. There's a typical problem.
Yeah,
in
more
this,
than happy to have that. But yes, and you do bring up a good point. Like by nature, how do you lock down security at node level? Then which means your worker node should have visibility into the namespace schema in some ways, which we don't have today in Kubernetes, with which we can potentially do it, or the pod IP range, which is anyway a private range again. So we don't really mount into that network because that network, unless and until you have a bridge within the worker node that can redirect your L2 or L3 traffic into the private network, which it is a yes and no depending on what sort of environment it is. It's not possible in the hyperscaler, but it is definitely possible in on-premises. Again, depends on which Kubernetes platform. I don't think CoreOS would be able to do that, but Ubuntu or something like that, if that is a worker node, it is definitely possible.
Arvind.
Yeah.
Yeah, I think so. All we discussed, right? It's all about the connected mode, right?
Sorry.
So connected mode, because CSA keeps retrieving the secrets data periodically and send it to the application, right? How this works in disconnected mode?
So can you just define what you mean by connected and disconnected?
No, no. In Azure, we have two different mode. One is a connected and disconnected mode.
Oh, air gapped. Okay, like DMZ and MZ is what you're talking about.
Um, I'm not sure actually. Yes, yes, exactly.
Okay, yeah. So here what we do is we don't interfere with the data plane at all. All operations that we do is on direct cube API port 6443. That's the only thing that we use. So as long as you have access to 6443 from the control plane, that is good enough to take care of all the operations. We don't directly interfere with the data that is there in the PV by any means. I mean, when we do a backup, we still move the data, but that data moves directly to the worm protected backup target, which for which you need a direct network from there. So it's not necessary that the control plane needs to interfere in that data move. So control plane will just say that, hey, by the way, it's time for you to do a backup. If you have scheduled it, the pod that is there within your environment will need to a data mover will be deployed there, which will move the data or your backup into the target. So it is just a facilitator of operations, but not sitting in the pathway of the source and destination. So we are very clear of that. So only 6443 is what we use.
Thank you.